Welcome to AI Unraveled, your daily briefing on the real-world business impact of AI. If you're a CTO or a head of MLOps, you've heard the promise. Synthetic data is the panacea for privacy. It's supposed to be the perfect anonymous solution that solves the utility versus privacy trade-off, allowing you to build powerful models without touching sensitive PII or running afoul of regulations like GDPR. But that promise is an illusion. In this essential special episode, we dissect the generative data problem. We assert that synthetic data is not inherently anonymous and remains vulnerable to sophisticated attacks like membership inference and linkage attacks that exploit model memorization. We also break down the critical long-term threat, the risk of model collapse when AI systems recursively train on purely synthetic data. But first, a crucial message for the enterprise builders. Stop marketing to the general public. Talk to enterprise AI builders. Your platform solves the hardest challenge in tech, getting secure, compliant AI into production at scale. AI Unraveled is the single destination for CTOs, VPs of Engineering, and MLOps heads. Secure your mid-roll spot. The link is in the show notes. Tune in to discover the hybrid solutions and the new governance mandate required to truly trust your generative data. Let's unravel the synthetic data problem.
Welcome back to the deep dive. If you're following AI at all, it feels like we're right in the middle of this huge tug-of-war.
Yeah, definitely.
On one side, AI models are just incredibly hungry for data. I mean, massive amounts of high-quality data. It's the absolute lifeblood for machine learning.
Can't do anything without it.
But then on the other side, you've got this absolute necessity legally, ethically, to protect people's privacy. We're talking PII, IPI, GDPR. The consequences for getting it wrong are huge.
Absolutely catastrophic fines, yeah. It's this fundamental trade-off, and honestly, for years, it felt like companies were just stuck. They needed that sensitive data for breakthroughs, but touching it, way too risky from a regulatory standpoint.
So everyone was looking for, well, magic bullet, really. And along came synthetic data. This was pitched as the ultimate privacy panacea, the tech that could finally let you have your cake and eat it too. Keep the data's value without the privacy nightmare.
The promise was incredible, right? Guaranteed privacy, plus data that's still useful for AI. Honestly, it sounded almost too good to be true.
And maybe it was.
Yeah.
So that's our mission for this deep dive. We're going to dig into the sources and figure out why this synthetic silver bullet isn't quite so simple. We need to understand why synthetic doesn't automatically mean anonymous.
There's a big gap there.
We'll cover the legal side, the sort of compliance illusion it creates, the technical weak spots, and the brand new governance headaches that come with it.
Yeah, it's a whole new set of challenges.
All right, let's dive in. So before we had these fancy generative models for synthetic data, people were trying other things, right? Trying to de-identify records. Why didn't those older methods really cut it?
Well, the main issue with those predecessors, things like pseudonymization or masking, they weren't actually generating new data. They were just altering the original stuff.
Like changing names or social security numbers to fake ones?
Exactly. You replace the direct identifiers. But the problem is it's fundamentally reversible. Somewhere, there's usually a key that links that fake ID back to the real person. And regulators, especially under GDPR, they see right through that. If it can be relinked, reasonably speaking, it's still personal data.
So you keep the data pretty useful, the utility's high.
Right, utility's decent.
But the privacy protection, not really there. The risk hasn't gone away.
Precisely. You're still managing risky data.
Okay, what about the other main approach? Things like K-anonymity. The sources say this one kind of failed in two opposite ways at once. How does that work?
Yeah, this is where it got really tricky. To make data anonymous using those older techniques, you had to seriously mess with it. You'd group ages into broad ranges, maybe drop unique zip codes. Basically, generalize and suppress details.
Okay, I can see how that would wreck the data from machine learning. AI needs those specific patterns, right?
Totally. Modern ML models thrive on complex relationships, correlations. If you feed them data that's been heavily blurred or generalized, the model just won't perform well. Accuracy plummets.
So you kill the utility. But the weird part is, even after doing all that damage to the data's value, it still wasn't actually safe.
Nope, that's the kicker. Even data scrubbed almost into uselessness. It turned out to be surprisingly brittle. Researchers for decades kept finding ways to re-identify people. They'd take some public info, link it back to supposedly anonymous data sets. Think about things like the Netflix prize dataset incident.
Right, famous example.
It just eroded trust. Organizations were basically paralyzed, can't use the real data, anonymized data is useless and still risky. What do you do?
Which sets the stage perfectly for synthetic data. What's the core difference here? How does it get around just masking things?
Synthetic data is fundamentally different. It's generative. Instead of tinkering with real records, you start with a generative AI model, like a GAN or a VAE. You feed it the original sensitive data as training material.
And the AI learns the patterns from that real data.
Exactly. It learns the statistics, the distributions, the complex correlations, all the underlying structure. Then, based on what it learned, it generates a completely new artificial data set from scratch.
Ah, so no original records are copied over.
Correct. The output looks and behaves like the real data statistically, but there's no one-to-one link back to any actual person in the original set. That's the key difference.
That technical leap is what built the whole business case. Our sources call it the threefold promise. Promise one seems obvious. Privacy.
Yeah, that's the main sell. Break the one-to-one link, no PII, so theoretically you're compliant with GDPR, IPPA, CCPA right out of the box. You can share it, build models, innovate without that constant regulatory fear hanging over you.
Okay, promise two. Utility. This is what traditional anonymization failed at.
And this is crucial. Good synthetic data aims to preserve those intricate statistical relationships. So an ML model trained on the synthetic set should ideally perform almost as well as one trained on the real thing. You get privacy and accuracy.
And the third promise. It deals with not having enough data or having biased data.
Right. Data scarcity and bias. If you need more examples of something rare, like a specific type of financial fraud or an uncommon medical condition, the model can just generate more high-quality examples.
Augmenting the data set.
Exactly. And potentially, you can even tweak the generation process to deliberately rebalance the data set, maybe to counteract historical biases present in the original data. It really looked like the perfect solution.
Okay, perfect on paper. But as our sources point out, this is where the compliance illusion creeps in. Let's unpack the legal side first. Why is it a mistake to just equate synthetic with anonymous?
This is where the technical world bumps up against the legal reality. Synthetic describes how the data was made, a technical process. Anonymous, though, that's a legal status. It describes the outcome, specifically the risk of re-identification.
So regulators don't care how you made the data. They care if someone can still be identified from it.
Pretty much. Just using a GAN doesn't automatically get you off the hook.
Yeah.
The gold standard, especially under GDPR's recital 26, is about the result. Is the data subject not or no longer identifiable? You have to demonstrate there's no reasonable likelihood of re-identification using all means likely to be used.
That sounds like a very high bar. The sources lay out this kind of three-pronged test attack vectors that any data needs to resist to be legally anonymous. What are they?
Yeah, regulators look at three main risks. First, singling out. Can an attacker pick out one specific person's record in the data set, even if they don't know who it is yet?
Okay.
Second, linkability. Can they link records? Either linking two records within the synthetic set that belong to the same person, or more commonly, linking a synthetic record to external public information to reveal identity.
Makes sense.
And third, inference. Can an attacker deduce new, sensitive information about a known individual with high confidence just by knowing the properties of the synthetic dataset or querying the model?
And if your synthetic dataset fails on any of those?
Then, legally, it snaps right back to being treated as personal data. All the GDPR rules apply again, as if you hadn't synthesized it at all.
Wow. So the burden doesn't disappear, it just changes form.
Exactly. That's the governance burden shift. Companies thought they were ditching the headache of managing PII. Instead, they swapped a known problem controlling access to static data for a much more complex, dynamic one, governing the generative process itself.
Meaning you constantly have to prove the model isn't messing up.
Right. You need ongoing, sophisticated technical audits to prove that the generative model, this kind of black box, hasn't overfit the training data in a way that makes the output vulnerable to these singling out, linkage, or inference attacks. It's a huge technical challenge.
Which leads us nicely into those technical vulnerabilities.
Yeah.
Where does the theory meet the road in terms of actual breaches? Let's start with the model's memory.
Okay, so this is often called the memorization problem, and it enables what are known as membership inference attacks, or MIAs.
Membership inference, meaning trying to figure out if someone's data was in the original training set.
Precisely. Generative models, especially if they're tuned for high accuracy or trained on data with really unique individuals' outliers, can sometimes essentially memorize parts of specific training records. They overfit.
Why would an attacker want to know that? What's the harm?
Well, imagine a synthetic dataset generated from patient records for, say, a cancer prediction AI. If an attacker can prove, using an MIA, that your specific record was used in training that model, they've just inferred you likely have or are at high risk for cancer. The confirmation itself is the data breach.
How do they technically do that? Query the model somehow?
Yeah, there are various ways. One method involves querying the model specifically for a JAN, the discriminator part that learned to tell real from fake data. You feed it the target record you suspect was in the training set. If the discriminator says, yeah, that looks really real with high confidence, it strongly suggests that record was indeed part of the training data it memorized.
That's pretty concerning. But the sources seem even more worried about another issue, especially with unique data points, the outlier problem and linkage attacks.
This is probably the most potent and well-understood risk, actually. It leverages those unique individuals, the outliers. And synthetic data can make it worse because often the whole point is to achieve high fidelity, to capture exactly those unusual, valuable patterns, like sophisticated fraud tactics or rare disease markers.
So the model is designed to replicate the outliers well.
Right. So how does the attack work? An attacker uses publicly available information, things like ZIP code, age, occupation, maybe public records, what we call quasi-identifiers or QIs.
Correct.
They look for a combination that's unique in the public sphere. The classic example. There's only one 45-year-old brain surgeon living in Beverly Hills, ZIP code 90210.
Got it, a unique public profile.
Exactly. Then the attacker goes to the synthetic dataset. Maybe it's a synthetic health dataset released for research. They search for a synthetic record that matches those same QIs. 45, neurosurgeon, 90210.
And because the model was built for high fidelity,
it likely generated a synthetic record that accurately reflects that unique, real person's pattern it learned from the training data. Boom. The attacker links the public identity, the neurosurgeon 90210, to the sensitive info in the synthetic record, like a specific diagnosis or procedure. Research shows this isn't just theoretical, it's quite feasible, especially when model accuracy is prioritized over robust privacy checks.
this feels like a fundamental conflict then. The better the model is at its job capturing reality, the worse it is for privacy.
You've hit it exactly. It leads straight to what some researchers call the impossible trinity. Synthetic data generation is constantly trying to juggle three competing goals. Fidelity, how accurately it captures the original data's patterns, especially outliers. Utility, how useful the synthetic data is for training ML models. And privacy, how resistant it is to re-identification.
And you can't have all three maxed out at the same time.
Never. It's a trade-off. If you want maximum fidelity and utility, especially capturing those valuable outliers, your privacy is going to be low. If you want to absolutely guarantee privacy in a mathematically rigorous way, you have to use techniques like differential privacy or DP.
What does differential privacy do?
DP involves injecting carefully calibrated mathematical noise into the process. This noise effectively masks the contribution of any single individual, especially outliers, making linkage attacks much harder, theoretically impossible at certain levels.
But injecting noise sounds like it would hurt the data quality.
Oh, it does. That's the trade-off. Studies have found that applying DP strongly enough to meet strict anonymity definitions often results in a near-complete loss of feature correlation. The subtle patterns ML needs are destroyed. The data becomes, quote, effectively useless for many complex downstream tasks.
So you're forced to choose.
Yeah.
Useful data that might leak privacy, or perfectly private data that's not very useful.
Exactly. And this choice can't be an accident. Governance teams must make a conscious, strategic, documented decision for every single synthetic data set they create and use. What are we prioritizing here? Fidelity, utility, privacy. You have to pick your point on that spectrum.
This need to compromise, to make these difficult trade-offs, seems to open the door to even bigger problems, systemic risks that affect more than just individual privacy. Let's talk about algorithmic pollution. First up, bias amplification.
Yeah, this is a serious one. Remember, one of the promises of synthetic data was potentially reducing bias. But the reality is, it can easily do the exact opposite.
How so?
If your original training data reflects historical biases, maybe loan data showing lower approval rates for a certain demographic, the generative model learns that bias. But it doesn't just replicate it. In trying to efficiently model the main patterns, it can actually amplify the bias. It might forget, or smooth over the characteristics of the underrepresented group even further in the synthetic output.
Which creates a dangerous feedback loop, right?
A really nasty one. Biased real data leads to amplified bias in synthetic data. Then you train new AI systems on that more biased synthetic data, leading to even more biased decisions in the real world, which then generates even more biased data. It can spiral.
That puts a huge burden on organizations to check for this.
Absolutely. Rigorous fairness audits before using synthetic data in any sensitive application. Hiring, loans, healthcare have to become standard practice. Otherwise, you risk embedding and scaling societal inequities algorithmically.
Okay, algorithmic pollution part 2 sounds even more existential for AI development. Model collapse.
This is the curse of recursion, and it's a huge long-term concern. It's what happens when AI models start training predominantly on the output of other AI models.
Because the internet is getting filled with AI-generated content.
Exactly. As more text, images, and maybe eventually other data online becomes AI-generated, future models trained by scraping the web will inevitably be learning from this synthetic secondhand information, not pure human data.
And the sources describe the result as degenerative. What does that mean for the AI?
It means the models start to lose touch with the true complexity and diversity of real human-generated information. They forget the nuances, the creativity, the weird long-tailed distributions, the important outliers. Each generation trained on the previous one's synthetic output tends to become a bit more averaged, a bit more generic, less diverse.
They sort of converge on a bland, simplified version of reality.
Yeah, they can kind of collapse inward, losing richness and accuracy, potentially becoming increasingly nonsensical over time, as one source put it. They forget the richness of the original human ground truth.
If the public data pool gets contaminated like this, what does that mean strategically?
It means the value of genuine, high-quality, uncontaminated, human-generated data goes through the roof.
Ah, the ground truth.
Precisely. That becomes the most critical strategic asset because it's the only reliable way to check if your models are drifting, the only way to potentially correct for model collapse. This creates a massive advantage for organizations that already have huge pre-contamination archives of human data.
Like the big tech incumbents, Google, Meta.
Exactly. They hold the pristine pre-2023 data libraries. Newcomers or smaller players might be stuck training on the increasingly polluted public web, creating a real lockout effect, and centralizing AI power even further.
So it's clear synthetic data isn't this simple fix. It's powerful, yes, but it transforms risk. It doesn't eliminate it. The sources suggest the path forward isn't choosing between real and synthetic, but finding a smarter hybrid approach. More about governance.
Yes, the focus has to shift. It's less about just controlling static data storage and more about dynamic AI governance. You need frameworks like the NIST AI Risk Management Framework to oversee the behavior and the output of these models throughout their entire life cycle. It's about managing the process, not just the initial data.
Okay, but a pure synthetic data has these risks, especially for sensitive data spread across different places. Is there a better architectural way?
There is, and a key alternative is federated learning, or FL.
Federated learning. How does that work?
FL is kind of privacy by design because it flips the usual script. Instead of pulling all the sensitive data to a central server for model training.
You send the model out to the data.
Exactly. The global AI model travels to where the data lives, could be individual hospitals, different banks, even your mobile phone. It trains locally on that data, which never leaves its secure environment.
And what gets sent back centrally?
Only aggregated, anonymized updates to the model. Things like updated weights or parameters. The raw PII stays put. This inherently protects privacy. And importantly, because it's always training on fresh, real-world data at the edges, it helps avoid model collapse.
But FL isn't perfect either, right? What are its limitations?
The main challenge with FL is that it can sometimes be slow to converge, meaning slow to train the global model effectively, especially if the data held in different locations is very diverse or heterogeneous. Each local model sees only a small, potentially skewed slice of the world.
Okay, so how do synthetic data and federated learning potentially work together, this better together idea?
This is where things get really interesting. You can use synthetic data strategically to help federated learning.
How?
Remember how we said differentially private DP synthetic data is very private but maybe less useful on its own?
Yeah, the utility trade-off.
Well, you can generate a DP synthetic dataset centrally, capturing some general patterns in a privacy-preserving way. Then, you share that synthetic dataset with all the local nodes participating in the federated learning process.
As like a starting point. A hot start.
Exactly. It gives each local node a better initial understanding of the overall data landscape before it starts training on its own local data. This privacy-preserving synthetic primer can significantly speed up the convergence of the main FL model. Some studies show improvements and up to 30% faster training.
That's clever, using the strengths of one to offset the weakness of the other. Are there real-world examples of this kind of hybrid approach?
Definitely. The Google Gboard example in the sources is a great illustration. They use federated learning combined with differential privacy DPFL to train the keyboard's predictive text models. Your typing data stays on your phone, protected.
Okay, so that's the FL part. Where does synthetic data fit in?
They also use large language models, LLMs, to generate synthetic conversational data for more general model training. But here's the key. They use insights derived from those privacy-preserving DPFL models, they call them buttress modules, to guide the generation of the synthetic data by the LLMs.
So the private real-world patterns learned via FL help ensure the synthetic data stays realistic and useful without leaking specifics.
Precisely. The synthetic data acts as a kind of privacy-preserving bridge. It helps improve both their large general models and the smaller on-device models, informed by real usage patterns via FL, but without compromising the raw user data. It's a really sophisticated, engineered privacy architecture.
It really highlights that privacy isn't just a policy anymore. It has to be built into the system's design.
That's the new mandate, absolutely.
So wrapping this all up after our deep dive, what's the single most critical action item for any organization looking at or using synthetic data today?
I think the biggest takeaway is this. Synthetic data is not a compliance shortcut or an easy button. It's a powerful tool, yes, a privacy-enhancing technology, PET, but it fundamentally transforms your risk landscape. It doesn't eliminate risk, it changes it, demanding much more sophisticated governance.
Which means accepting that governance burden shift we talked about. You need serious auditing.
You absolutely do. Don't let any synthetic dataset out the door for use until it's been rigorously stress tested. That means running simulated membership inference attacks, running linkage attack simulations against it. You have to actively try to break its privacy.
And quantify that impossible Trinity trade-off.
Yes.
Ah.
For every synthetic dataset generated, demand what the sources call a quality card. This card needs to clearly document the metrics. What's the measured fidelity? What's the utility score for the intended task? And what level of privacy protection, EAG, the differential privacy budget, or epsilon, does it offer?
So governance can make an informed, defensible decision.
Exactly. Is this data set for low-risk internal testing, where we prioritize utility? Or is it for external sharing, where privacy is paramount, even if utility suffers? That choice has to be deliberate, documented, and defensible, not an afterthought.
Makes perfect sense. And a final thought for our listeners to chew on.
Well, connecting back to those systemic risks, bias, amplification, model collapse, if you're thinking long-term strategy in the AI age, remember this. Your most valuable, most defensible asset might not be your fancy generative models. It's likely your unique, proprietary, uncontaminated archive of ground truth, human-generated data.
Because that's the ultimate reality check against algorithmic pollution.
It's the anchor. In a world potentially awash in synthetic data of unknown quality and bias, having that pristine, verifiable human data is an enduring competitive advantage. Protect it like the crown jewels.
That is definitely a provocative and strategic thought to end on. Thanks for diving deep with us today.
That wraps up our special episode on synthetic data governance. The major takeaway is that data privacy is not a binary state. Synthetic data offers utility, but it does not guarantee anonymity or compliance. You must assume that your models, even those trained synthetically, will memorize outliers and remain vulnerable to sophisticated technical attacks. The only viable solution is a hybrid approach. We advocate for integrating synthetic data with robust governance tools like federated learning and differential privacy to proactively manage the fidelity-utility privacy trade-off. This dual-pronged strategy is your new mandate for secure, production-ready AI. If you are leading an enterprise through this high-stakes shift, this message is for you. Stop marketing to the general public. Talk to enterprise AI builders. Your platform solves the challenge of getting secure, compliant AI into production at scale. We have reserved a limited number of mid-roll ad spots for companies focused on high-stakes, governed AI infrastructure. This is a direct line to your most valuable buyers, the CTOs and VPs of Engineering. Don't wait. Secure your mid-roll spot immediately. The link is in the show notes. If this analysis helps you build your strategic data plan, Please take a moment right now and like and subscribe to AI Unraveled. Thank you for tuning in. We'll be back tomorrow to unravel the next chapter in AI.